Hey everybody, welcome back. It's Monday. Hope you had a good weekend. I don't know if it's raining where you are, but it's raining where I am, and it's you know, not such a nice day. So I figured, why not wear an umbrella hat, right? Why not do that? So I see there's a number of people in here that keep coming back. That's awesome, Adam. I saw you turned in your egg drop. I'm gonna check that out in a little bit. Hopefully, there's a couple other people that are doing it, and I'll be sharing all that stuff in a little bit. Anybody that's on here right now planning on doing the egg drop? If you do, just mark it up there in the comments. Just give me an idea with the live chat there if you're going to be doing the egg drop. I know a couple people that I know are. A couple of the Barretts, Keely and Addie, are going to be doing that, I think. My own kids are going to be doing it. We'll have to post that. That's a winning hat. You like that one, Adam? That's a good one, isn't it? Yeah. Yeah, this hat is this has had quite a run, this hat. So people were asking me, what kind of stuff are we going to be learning about today? Well, I have a couple things on my agenda here from last week. A couple of things that kids wanted to hear about or know about. Let me pull up what I got here. Ayushma asked me about why the sunrise and sunset are different colors. Going to get to that in a little bit. Also, I wanted to talk about how the stars in the sky look now and if they actually really look like that. And I also am going to go through, Alana has asked me twice now, why we have gas in our bodies. So that's going to be fun. We'll take care of that in a couple minutes. And I know Jordan wanted me to play Blackbird on my guitar. So I'll get to that in a couple minutes too. And I think big number 88, Aiden, has been to every one of these, and I know there's a couple other of you that have been to this too. I know Sophia's been here every time. There's been quite a few. Clayton's been here. It's great. So we're just gonna keep it going. Why not? Why not? We've got nothing but positive things to say, so let's keep it going. I don't know if Michaela's online right now, but I told Michaela I'd give her a shout out too. So Michaela, if you're listening, what's up, girl? Torn's back. What does the Zamboni do for hockey? That's a good question, Torn. I can answer that because that was just about our other one. The Zamboni, its job is to literally go over the ice, melt it just a little bit, and then all those little skate marks in the ice that fill with water, and it immediately refreezes. So the Zamboni's job is literally to smooth out the ice again, takes all those skate marks out of there, and it will refreeze so that when the players come out, onto the ice for the next period, it's smooth, just like a brand new surface. Okay, I see Cole's here. Awesome. Yeah. Oh, Mrs. Prime's here again. Oh, it looks like, okay, I see what we're doing there. All right. Keely and Addie are here. Awesome. Good. There's Michaela. I knew she was coming today. Very nice. Very nice. All right, well, let's get to it. I'll talk about what I wanted to talk about first, and then I'll get to the other questions because it looks like some of the people who want to know some things aren't quite here yet. So the first thing I want to talk to you about is stars. Stars in the sky. All right. We know from our class when we look up at the stars in the sky, there are literally hundreds of billions of stars, trillions and billions of stars in the sky. We know that there's more stars in our universe than there are single grains of sand on the beaches and all over the earth. So imagine that. Like and if you guys have had me in class, you know this, but imagine being at the beach and having a pile of sand in your hand and letting all the sand grains run out of your hand except for one little piece of sand. Now imagine how many of those little pieces of sand are all over the earth, on all the beaches, underneath all the oceans, in all the sandboxes, beach volleyball courts. There's more stars in our universe than there are single grains of sand on the earth. That's like a mind-blowing thing. All right, now here's what I want to talk to you about today about stars, though. We talked in class about how sometimes when you look up at the stars that you're looking at might not actually even be there anymore. They might not exist. And when you look up at the stars, you're looking back in time. So you're actually going back in time and looking back in time when you look at the stars. Let's figure out why. So we know from stars go through a life cycle. They're not alive, okay? But they do have a cyclical life, all right? Meaning they start and they end in the same place. So what happens is we have two different kinds of stars. We have average-sized stars like our sun, and then we have massively huge stars, all right? When they go through their longest part of their life stage, it's called the main sequence, all right? It goes for hundreds or billions of years. That's how long stars will stay alive. What they do is they fuse hydrogen and helium in their core, and they make massive explosions. They create new elements, all right? Eventually, they're going to start to run out of that hydrogen, and they're going to start to grow because gravity's not going to be able to hold on to them as much because they're not as powerful. There's not as much going on inside the star, so they're going to start to grow. Our sun, in about 4.5 billion years, not anytime close, is going to turn into a red giant. Okay? It's going to be massive. And in fact, it's going to grow so big that it's going to eat Mercury. It's going to eat Venus. And they're not quite sure yet if it's actually going to eat Earth or if it's going to stop just before Earth. But either way, Earth is going to be not anywhere near what it's like now. All right? We're going to have no water if it stops before us. It's all going to evaporate. We're going to have no atmosphere. We're just going to be a hot, burnt rock. Okay? But all those gases that the sun produced are going to drift back off into space, and we're going to be left with a little teeny tiny star called a white dwarf. And that is about the size of the Earth. So imagine the sun being the size of the Earth. All right, but the big stars, the huge stars, they explode in a supernova, and then they turn into either a neutron star or a black hole, which is everybody's favorite space term. My thing is I like these neutron stars because it's really hard to imagine how dense they are, how much stuff is packed inside those stars. They're super tiny. They're no bigger than a city out in space. They're super tiny, but they're super dense. If you can go out with a spoon and take one spoonful of that star, it would weigh over 100 million metric tons, one spoonful. If you don't know how much that is, take every single car on the Earth, and stack them up on top of your spoon. That's how much they would weigh. Okay? But to my point about why when you look up, they're not there, we know they're light years away from us, meaning it takes light years to get from that star to our eyes here on Earth. Okay? So let's say you just go outside, and obviously not tonight because it's raining out, but you go outside and you look up. With just our naked eye, we can see about 9,000 stars in our sky at nighttime. Good luck counting them all. 9,000 stars. And those stars are all still there. I'm talking about when you look through stars or look at stars through telescopes that they might not be there anymore, and I'll get there in a second. But if you just use a pair of binoculars, you look through the binoculars up at the sky at night, you can see about 200,000 stars. And then if you have a telescope, just one of those little telescopes, about that big, a 3-inch telescope at your house, you can see over 2 million stars. All right? Now think about those stars that are really far away from us. Let's say there's a star that's 100 light years away from us, meaning it's taken light 100 years from that star to get to our eyes. So when you look up at that star, that's 100 light years away. You're not seeing what that star looks like right now. You're seeing what that star looked like 100 years ago. And that's pretty amazing if you think about it. You're looking back in time. If you're using a telescope and looking further out into our universe, and you're looking at a star that's 100,000 light years away, you're not seeing what that star looked like today. That's what that star looked like 100,000 years ago. Now imagine this. Let's say you have a favorite store on the West Coast in Los Angeles, all right? And you live over here on the East Coast, right? You visit your store. That's the star, okay? That's the star, your store on the West Coast. And you get in your car and you start driving from that favorite store on the West Coast, driving back to the East Coast. You and your car are light. You're the light from that star. So you've left the star. You've left the store on the West Coast, and you're driving all the way back to the East Coast. Now, on your drive, the people on the East Coast that you're going back to, they know that store. They think that store is still there because you were just there, right? But it's going to take you 4 days to drive from the West Coast back to the East Coast. Well, in those 4 days when you were driving, somebody tore down that store, okay? Somebody tore down that store. It's gone. But as you're driving, you're the light coming from that star, from that store to the East Coast. As you're driving, by the time you get to the East Coast, to your house, and those people that you're driving to look for your store, it's gone. But you, the light, had just gotten there. All right? Now, the next time you go to the store, you look up at that star, it's gone. It's not there. Okay? So I think that's pretty awesome. You can see a star in the sky that might not even exist in our universe anymore. It could have exploded 200,000 years ago, but because it's 200,000 light years away, we wouldn't know that until now, because that's how long it took the light to get here. Okay? So, I think it's pretty cool stuff. Not sure about you, but I do. But I'm a science nerd, so we all know that. Now, let's see what else we have here. I'm trying to see if we have any people who wanted to know these things. If not, they can watch them later. Let them know I talked about their thing on the live stream today. So next thing I want to talk about is, let's go to this. Ayushma wanted to know why the sunrise and the sunset are these really awesome, brilliant colors. Because they are. They're really cool. Well, first of all, if you want to know why the sunset's one color, you got to know why the sky's blue to begin with. So, yeah, like I said, we bounce all over the place here in this live stream. It's fine. Now, when the sun shines down, it sends light down to Earth, obviously. Okay? When that light from the sun hits our atmosphere is made of gases. Okay? And gases can act like a prism. And when the light shines through our atmosphere, it actually gets broken up into different colors. All right? All the colors that reach our eyes, the red, the yellow, the green, the purple, they combine to make what looks like white light from the sun. If you look up at the sun, which you shouldn't do anyway, the light from the sun is pretty much white because it's a combination of all those other colors coming down. However, the blue light that gets broken up into the electromagnetic spectrum, the blue gets scattered by the molecules in our atmosphere. It scatters that light all over the place. Okay, and you can see it here. Those particles scattering that blue light make the sky itself look blue because it's blue light from the sun. All the other colors are getting to us. That's why the sun looks like it's white light from the sun. But that blue light's getting scattered all over the place. When we look up, that's why our sky looks blue. So now why then does the sunrise and the sunset have different colors? Well, this is kind of cool too. So here's what I'm talking about. When the sun's high in the sky, we see the white light coming from the sun. The blue light gets reflected. Okay, the blue light gets reflected. You know what? I don't know if you can even see this. I probably need to do this. Look at me. Sorry. I'm getting excited talking. I'm forgetting what I'm doing. Anyway, the blue light, all right, gets scattered. We see blue, all right, blue sky, white light from the sun. By the way, I'm just going to go back here. This is the slide that I showed you that you couldn't see because my face was over top of it. So I'll put all this stuff in School Juice. If you want to go check out these links, you can. So here we go. That's the blue. Now, why does it look different at sunrise and sunset? Well, here's why. Here's why. When the sun goes down in the sky and it looks closer to our horizon, the sunlight actually is traveling through more of our atmosphere to get to your eyes. Okay? And that blue light is still being scattered about. All right? However, other colors are starting to get scattered about too, because of the distance it has to travel through our atmosphere to get to our eyes. And then what we see is the reds and the yellows and the oranges from that scattering of light that comes to our eyes. And if we have those cirrus clouds up in the sky, they reflect that light off those ice crystals that they're made out of, and the sunrises and sunset off of cirrus clouds are spectacular. So the reason why the sky looks different is because of the light being scattered as it comes through our atmosphere. During the day, the big part of the day, that light looks white from the sun because all those colors are combining. And the sky looks blue because that blue light's getting scattered all over the place. But then at the sunrise or the sunset, that sunlight has to travel at more of an angle through our atmosphere to get to your eyes. So more of that light's going to be scattered, but the reds and the yellows and the oranges are going to meet your eyes. And that's why the sunlight looks so cool at sunrise and sunset. All right? So that's that. I thought that was pretty cool to talk about too. That was Ayushma who wanted to know that. So here's what I do, guys. Those of you who have questions, what I do is after the stream's over and I end my live stream, I go back and I look at all the comments. I look at all the chats. All right, I look at all the live chat. If you have a question, ask it in there, and I'll make sure that I get to at least mention or talk about your topic that you want to know about on our next one. Okay, we've got 20 people in here. That's great. So we got one more to talk about. Is that Messiah I see there too? Nice. Good. All right, so keep asking me your questions. I got one more thing to talk about, and this is the one that Alana wanted to know about. And I don't think she's here right now, but if she is, awesome. If she's not, tell her, if you know her and have her number, to check out the web stream for today, because this is going to be funny stuff. Now, let me find the, you know what I have to do? I have to go back and find the website I used. Let me get there. I got multiple computers running here. Let me find. Now, I think we'll find this one rather humorous. That's why I saved it for last. Because it's kind of funny, and it's about farts, and who doesn't like that topic, right? Who doesn't like that? All right, here we go. This is the website I want to use because they have an awesome infographic that's going to tell us about why we have this. So Alana wanted to know, why do we have gas in our body, right? Well, there's a couple ways to get gas in your body. One is when you're eating and you're eating really fast, sometimes you swallow air. And when you swallow air and you don't burp it all out, it gets digested and goes through the rest of your digestive tract. Okay, if you drink a lot of carbonated sodas and things like that, you're going to have more gas than people who don't, because that's all air that's going into your insides. But that's not the main reason why we have gas. Here's the truth about gas. It has to do with other things inside your body. Right now, all of us sitting right here have over 500 different types of bacteria in our intestines, in there, okay? And it's digesting your food. And when different materials get digested by these bacteria, well, just like you have to go to the bathroom, well, bacteria also have to go to the bathroom. And gas is a byproduct, a waste product of those bacteria in your intestine. Now, here's something interesting. In one day, you can produce 1 to 3 pints of gas. And you pass gas 6 to 20 times a day. Average person, 14 times. Whew, man, I guess my family thinks I'm above average. I don't know. So here's the gas thing. Why? Breaking down undigested foods in the small intestine. All right? And then we have, it's called aerophagia. So it's a really scientific name, aerophagia. It just means swallowing air. Okay, so you get gas by 2 reasons: digestion and aerophagia. All right, eating and drinking large amounts. Here we go. As foods and liquids and gases enter the mouth, they go through your esophagus, all right, down into your stomach, your pancreas, your liver, your gallbladder, all right, and then this down here, the intestines. Mr. France would be happy I'm talking about this kind of stuff. This is where the bacteria takes over and starts to digest your food. Okay, this is where the gas is produced, Alana, right there inside your belly, inside your intestines. All right, so what's that gas made out of? 1% of it is a gas that makes your gas smell like sulfur. That's gross. 99% of it is made up of nitrogen, hydrogen, carbon dioxide, oxygen, and methane. Those ones really don't have an odor. So it's just that 1% of the gas that your body produces that makes you stink. All right, we get sulfur compounds, that 1%, and they can create different things. We have hydrogen sulfide. That's if you kind of smell like rotten eggs. It's the most common smell of flatulence. That's the scientific word for a fart, if you didn't know. And then we have methanethiol. That would be smell similar to rotten vegetables. Ugh. And dimethyl sulfide, which produce a sweetness of your smell. Ugh. This is kind of gross, but that's all right. Well, we have different foods that cause more gas, okay? Things like garlic and onions and asparagus and fruits high in fructose, milk, yogurt, they'll give you some gas. And then foods that will make you really stink: meat, poultry, eggs, onions, broccoli, cabbage, Brussels sprouts, and cauliflower. Well, they just stink to begin with if you pick them up and smell them. I know some of you are cringing at the mention of those vegetables. Ew. So there you go. There we have it. That's why we have gas, Alana. That's why we have gas in our bodies right there. It's all from our food and from our digestion. Like I said, I'll put these links in the in Schoology. I haven't done that yet. So, just a couple housekeeping things. Mr. Scheuch, I'm not in this class. That's fine if you're not in this class. You don't have to be. All right? You don't have to be. So, keep your questions coming. I don't see Jordan here, but I'm going to play his song for him, even though he's not here. Just because I like playing guitar. Why not? And I have an audience, and you'll listen to how bad I am. I'm not going to sing this time. No singing. So, if you like the Beatles, this is a Beatles song called Blackbird Jordan. I'm just kind of zooming in on my guitar here so you can see the positions of things here. That's the song, and it just keeps going back and forth and over again. Yep. In case you joined late and wondering why I'm wearing a hat on my head like an umbrella, because it's raining out. Why not? Why not? All right, everybody, please do me a favor. Stay safe. Keep asking questions. If you want to do some of those optional assignments and turn them in for me, I'll be more than happy to take a look at them. Like I said, my kids are going to do the egg drop challenge. I'm going to put some of the results on there. I'm going to take some videos, post some pictures of the things that we're doing, maybe some eggs smashed on the floor. All right. But, yeah, Clayton, I love those vegetables too. So, seriously though, keep it coming. Keep the questions coming. I'll keep answering them, right? I'll keep answering them. Why not? And, if you want to know something, let me know. Oh, and I also wanted to know, or not to let you know, there was another earthquake in Salt Lake City last night. It was a 3.4. It wasn't nearly as big. It was an aftershock. In fact, remember I told you last time I have friends out there that lost power? We were actually having a Zoom meeting with them last night. There was a bunch of us talking, a bunch of friends. And right after we finished our meeting, we got a text that just said, "Yep, another earthquake out here." So again, it's that fault movement where one's trying to go down and one's trying to go up, and it just builds up that stress, and we get that release of seismic pressure right there, and we get an earthquake. So hopefully, that's not going to happen again. They're called aftershocks, but that's all right. All right, so let me wrap this up. There's going to be a folder. I'll put the links of all the pictures and the things I put in there so you can see them. I didn't add any writing assignments this time or any creative stuff. I'll do that. I'll add a creative writing assignment. I do want to let you know where I get my creative writing assignments from. This book is awesome. If you don't have it or have never seen it, it's called Write the Story. I got it at Five Below, and it's an excellent way to just get your brain thinking about things, be creative. So what you'll do is it tells you in here. Let me just give you this for example. It says right here, 5 people with completely different backgrounds seated together. And then it gives you a list of the words that you try to use in your story. So they'll give you the words that you try to use in that story, and your topic is 5 people sitting around together that have different backgrounds, they don't know each other, and you have to use those words. That's not the one I'm going to use today, though. That was just an example. But if you want to do that one, go for it. All right, I'm done rambling on, ladies and gentlemen. I hope that you have a wonderful evening, and let me know if you have questions. I see some people already did the egg drop. That's awesome. Ooh, it fell out of the production but still survived. Did you hard boil it? All right. My biggest question is what happens when you die? You know what, Torrin? I wish I knew that, but nobody does. Nobody does. All right. Why do mammals have hair and not reptiles? This is great stuff. I'm going to answer these on Tuesday. Today's Monday. Enjoy your Monday thing. Do what you do on a Monday. I hope you guys are well, and I'll be back tomorrow. Have an awesome, awesome day, guys. We'll see you.